Question 1.1 says, determine the equation of the least squares regression line. Okay, guys, so that's an easy question. You just input all the values into your calculators. And so you guys know how to do this, but in case you are struggling, you just go to mode, and then you would go to the stat function. You would go to option number 2, input all your values. Once all the values have been put into the calculator, you push the AC button, then you push shift, then you go down to stat, choose option number 5, and then you can take out the values that you want. So we know that the equation of a least squares regression line is A plus BX. So we need to get A and we need to get B. The values that I got on the calculator for A was negative 1946.88, and then B was 0.41. And so that would be the answer for number 1.1. So I'm just going to say here 1.1. Moving on to 1.2. It says, if a person earns 14,000 Rand per month, predict the monthly repayment. Okay, so this over here, the top one is the monthly income, and the bottom one is the monthly repayment. So this is almost like your X, and this over here is your Y. So what we're going to do is we're going to take the monthly repayment, sorry, not the monthly repayment, the 14,000 Rand per month, which is an X value, and we're going to plug it into there. So it's going to end up giving us Y equals 2, and then I'm going to plug the value that they've given us, which is 14,000, and that gives us 7,686.88, and that would be in rands. So we would go like that, and then I would just take out the Y. So there's our answer for that one. Question 1.3. Determine the correlation coefficient. So guys, that's just your R value. So you go back to your calculator, and you don't have to go put all the values in again. You just go shift, and then you push the number 1, and then you go to number 5 again, and your values will still be there. So you just push number 3, and then push equals, and then we can round that to 2 decimal places. So that'll be 0.95. 0.95. For question 1.4, it's quite an interesting one. You've got a person who earns 18,000 Rand per month. So that means they are somewhere over here. Now, their monthly repayment on their car is 9,000 Rand. But guys, look here. For someone who earns 18,000 Rand per month, their monthly repayment should be somewhere between 5,500 and 6,000. So that would be about 6,750 Rand. 9,000 Rand is a lot more than that. So if I was this person, I would not spend 9,000 Rand per month on my car. So I would go for option D, because it says do not spend 9,000 Rand per month, because that point lies very far from the least squares regression line. That's true, because what that means is that the 9,000 does not fit into this data. And so what we said is that we would go with option D. And then just quickly, guys, I see for some reason this part over here is correct, but I might have typed it in on the calculator wrong. The correct answer is 3793.12. So if any of you watching this saw that, sorry about that. Moving on to question 2. I'm not going to read through all of this. The first question says, how many people pay 200 Rand or less? Well, there are 7 people who spend between 0 and 100, and there are 12 people who spend between 100 and 200. So the total number of people who spend less than 200 would be 7 plus 12, which would be 19 people. 5 is quite an interesting question. We have to try and calculate A and B. So we have, okay, and the first thing I want to highlight is that we have a total of 100 people. So if you add all of this together, it should give us 100. So we can make a little mathematical equation from that. I'm going to quickly add these numbers up. And if we had to add those numbers together, it gives us 60. That means that we still need another 40. So we can say that A and B together should equal 40. Now, they also tell us that the average is 309. I'm getting that from that part over there. So to work out the average on a table like this, you do the following. You take the middle number of the amount paid, so that'll be 50, and you say times 7, plus 150 times 12, plus 250 times A, so I'm just going to do that, plus 350 times 35 plus 450 times b, so I'm just going to do it like that, plus 550 times 6. And then for average, actually I need to write this out a little bit better. You would have to take all of that we've just written out, and you would have to divide that. Let me write that a bit better for you guys. You'd have to divide that by the total number of people, and that's 100. And I've written it out better for you guys, and then the answer to that should be 309. So what I would do, I mean, there's so many different ways you could do that, is I would take all of these values and I'd add them all together. We can't do the 250a, but we can add these ones and this one. I would add all of that together, which gives 17,700. Then, of course, we still have 250a and 450b. Then what I would also do is multiply this 100 over to the 309, and that would give us 30,900. Then what we can do is we can take our equation that we developed earlier and maybe get a or b alone. It doesn't really matter which way you do it. You can do it however you like. I'm just going to get a by itself, and that's going to be 40 minus b. I'm now going to take that and plug it into here. And so that's going to be 17,700 plus 250. Then in brackets, I'm going to say 40 minus b plus 450b equals to 30,900. And then it's just a matter of solving. And what we do find is that b is equal to 16. What you can then do is plug that b value back into there, and you would find that a is 24. 2.3, write down the modal class. The mode means the most. So what I do, and we should fill in our a values just in case, 24 and then 16 is over here. So the modal one is the one where there's the most, and that's 35. So the answer for that is going to be 300 to 400, like that. So here we have our ogive in the answer book. Now with an ogive, guys, all that you want to do is you want to use this number as your starting number, so we can see it's already 100, and then 0, and then you only want to use these values. You don't want to use the middle number. The only time we use the middle number is when we're trying to calculate the mean or the average. Now, the ogive also uses cumulative frequency. It doesn't use frequency, it uses cumulative. So we can make another little column over here, and cumulative is just when you add everything together. So it's 7, and then 7 plus 12 is 19, 19 plus 24, 43, 94, and 100. So these are the values that you are going to use on your cumulative, or in your ogive curve. So the first one is 100 and 7. So we go 100, and then we go up to 7. So we can see that these bars are going up in 2. So it's 2, 4, 6. So it'll be somewhere over there. Then it's 219. And there I've gone and plotted the points, and now you just try neatly connect all those dots together. There we go. So your ogive would look something like that. And then 2.5, determine how many people paid more than 420 Rand per month. Now guys, why is this question a little bit weird? Well, you can't answer this one from the table because this says 400 up to 500. It doesn't say 420. So what we do is we use our ogive curve and we go to 420, which would be over here. You would then use your ruler and draw a line going right up until it touches the graph, like that, and then where it hits your graph you go across. Now I'm getting an answer of about 82. Now in a test, they will give you a range of answers. You don't have to get it exactly correct. You could get a range between, like, I don't know, maybe 80 and 85. But we're not done. The reason we're not done is because they said how many people paid more than 420. So that's actually these people. So that would be all of this. Can you see that? Because it goes up and then it goes to the side. So all we do now is we say 100 minus our previous answer of 82, and that's going to be 18 people. 3. Question 3, the first one says to write down the equation of PR. Alright, so you see PR doesn't have, it's not like a normal y equals to mx plus c because it's completely horizontal. So any line that goes like that will just say y equals. And look at this, all the y values are 5. So that line is called y equals to 5. If it was a vertical line, we would call it the x equals to line. Okay, so the first one is y equals to 5. Then it says calculate the gradient of rs. I'm just going to do this quickly, guys. You know how to do this. So we're just going to fill in the gradient formula. And then I'm just going to go 5 minus 7 over 3 minus 3. And that's going to give us an answer of 2. For question 3.2.2, it says the size of theta. Now they've told us that these two lines are parallel. What that implies is that their gradients are the same. So we can say here that the gradient of PT is also going to be 2. Why? Because RS is parallel to PT. Now guys, remember from grade 11, we should know angle of inclination. So we can work out this angle by just using angle of inclination. So we can say on our calculator, shift tan of whatever the gradient of that line is, which is just 2. And that's going to give us 63.43 degrees. So I'm going to fill that in, 63.43 degrees. Next question for 3 marks says determine the coordinates of D. Now this is a very easy one. D is the y-intercept of the line RS. So if we can find the line or the equation of RS, then we can work out its y-intercept. So we know that a straight line is y equals to mx plus c. We already worked out the gradient of that line in question 3.1. Sorry, not question 3.1, 3.2.1. And we found that that was 2. Then to find c, you plug in a point, either r or s. I'm just going to plug in r. And if you go work this out, you're going to find that c is -1. And so that's going to... And so then we have the equation 2x minus 1. Now for some of you who know straight lines quite well, you would know that -1 is going to be the value of d. But if you don't, then you just make x equal to 0. And you're going to find that y is equal to -1. Therefore, the coordinates of d will be 0 for the x and -1 for the y. Question 3.3. It is given that the distance from ts is 2 square root 5. Calculate the value of k. All that we need to do in a question like this is use the distance formula. And so we can say here that ts, and then I'm just going to write out the distance formula, which is always going to be given to you in the formula or on the formula sheet. And then they've already told us what the length of ts is. It's 2 square root 5. So I'm going to write that over there. I'm then going to use this as my point number 1. So it's going to be -3 minus -5. Let me just make sure I've written 2 negatives there. Minus, and then -5. Sorry, -7 minus k. Okay, there are many ways that you could carry on from here. What I'm going to do is I'm just going to say 2 square root 5, and then I'm just going to neaten this part up. That's going to give us a 4. If you can go work that out on your calculator. When you square it, it's going to give you 4. And then this part I'm just going to leave as it is. So it's just going to be -7 minus k squared. Now, to get rid of the square roots, we're going to take the square on both sides. So we're going to square, well, actually let me put the squares over here in a different color. Like that, and like that. Guys, just type this part on your calculator, because sometimes people forget about that 2 on the outside there. And that's going to give you 20. So we can say 20. And then what happens here is that the square root falls away on the right hand side. So everything else stays the same. Even this 2 stays there. It's just the square root that disappears. Okay, now a common mistake I see with some students is they try and they say that that's the same as -7 squared and then minus k squared. You don't want to do that. There are 2 options that you have at this part. You can either multiply everything out and then you would get a trinomial. But what I like to do is I take the 4 over. So that's going to give me 16. Why am I writing in a different color now? Sorry about that. And that's going to give us 16 equals to -7 minus k squared. I then take the square root on both sides, and so that's going to give me plus minus 4. You don't have to do it this way. As I said, you can multiply everything out. A lot of students prefer to do that method. And then on the right hand side, you're just going to be left with minus 7 minus k. You see, because what I did is I took the square root on both sides. And so now I'm going to bring the k over to the left hand side. And then on the right hand side, you're going to have plus and minus 4. So if the 4 is positive, then you're going to get minus 7 plus 4, which is negative 3. And if the k is negative, you're going to get minus 7 minus 4, which is negative 11. Now, if we look at the location of this point, k is a y value, and it has to be negative. But it also can't be beneath point S. We can see from the diagram. So this means that k is going to have to be negative 3. Question 3.4 says parallelogram TDNS. Now guys, those letters are very important. It's going in the correct order. So T to D, then to some other value N, which we don't know where it is, and then it goes to S. And then S will obviously connect to T. So I'm going to connect these two together. Now I know that parallelograms have parallel lines, so I'm going to draw this line here, parallel, and then this one would have to be parallel, so something like that. So I know that this point here must be N. Now guys, there's a very easy way to do this. We already know D's coordinates. We knew that from question 3.2.3, so let me just write that, 0 and minus 1. What you do, and we also know K's coordinates. Wow, this is a weird question, because if you got the first parts incorrect, it makes it a little bit difficult. So K would be, what did we say, negative 3. So all that you do is you look at the point T and you look at the point D, and you see how does the x values change. Well, the x values went from minus 5 to 0, so they went up by 5, and then, or we can say to the right by 5, and then the y values went from minus 3 to minus 1. Now I'll be honest guys, there's a bit of a, not a mistake, but the people who set this exam paper have done something a bit weird here. This point K should be lower down than point D. So if you picked up on that at home, you are correct. Something is a bit weird here, but nonetheless, everything we've done so far is mathematically correct, but the person who sets up the exam didn't really check for these types of things. So it looks a bit weird, but to go from minus 3 to minus 1, your y values are actually going up by 2. So what we're going to do is we're going to do the same to point S. So point S is currently has a y value, an x value of minus 3. So if we add 5 to that, then it's going to end up being 2. So that's going to be the x value. And then the y values we said have to go up by 2. It looks like it's going down, but that's because the person who set this exam didn't really check for that. So if it goes up by 2, it's going to end up being 2 and negative 5. Question 3.5 is quite interesting. They tell us that the triangle PRD, which I've done over there, is reflected in the y-axis. So they're going to reflect it across that pink line that I've just drawn. Now, when you reflect something across the y-axis, let's say for example you have a point over here, then it's just going to jump over and end up over here. So this point R is going to end up somewhere over here, and we'll call that R with a little line to show that it's the reflection. Point P is going to jump this way and end up over here. So I'm going to label that point P with a little line. And then point D is on the y-axis, so it won't go anywhere. I'm now going to draw our new triangle that we have developed. Or actually, no, we don't want to do that because that's not what they're asking. What they're asking for is to determine the angle that goes from R to D and then to R with a little line. So from R to D, so let's do that in a different color. So R to D, and then from D to R with a little line. I'm going to call it R prime. That is the angle that they are wanting us to discover or to work out. That's this angle over here. What I want to show you is that this part over here, this angle, is going to be exactly the same as this angle over here. We can see that R and R prime, they are the same thing. They are just reflections of each other. So let me quickly show you what I'm trying to do here. this angle is going to be the exact same as this angle, because r and r prime are just reflections of each other. Okay, I hope that that part makes sense. So what we are going to do is we're just going to try work out this little angle, and then we'll multiply that by 2. So earlier on in question 3.2.2, we worked out the size of theta as 63.43 degrees. Now, that will be the same as this angle over here. Because those lines are parallel, they'll have the same angle of inclination. I'm then going to do vertically opposite angles to find this little angle over here, which will also be 63.43. Then I know that in this triangle over here, that is a 90-degree triangle, because it's using the origin, this part over here. That's always 90 degrees. So what this then means is that I can work out this little corner angle by saying 180 minus 63.43 minus 90 degrees, and that's going to give us a value of 26.57. Then I would times that by 2, because we said that this angle is exactly the same as this angle, so we'll multiply that by 2, and we'll find out that the answer is 53.40. Question 4.1 says determine the equation of the circle. Well, when you've got your x-axis and your y-axis as tangents to the bigger circle, as we can see like this, then we can easily know that this length over here is going to be 1, because we can look at a's coordinate. And then if we look at this part here, we can see that this length of that line is 1. So it means that the coordinates of m will be minus 1 and positive 1. And so now we can start getting the equation of the circle. We can say x plus 1 squared plus y minus 1 squared equals to r squared. Now the radius is also very easy. We know that this length is 1. You could also do it like this if you wanted to. So the radius is just going to be 1. And 1 squared is just 1. So we can say x plus 1 squared plus y minus 1 squared equals to 1. Question 4.2 says calculate the coordinates of C. Now it's only for 2 marks, so what I would do in a question like that is I would realize, well, they've told us that BC is a diameter, or BNC is the diameter. So this point C is, well, if you look at these 3 points, we could use the midpoint formula in reverse. So we know that the midpoint formula is x1 plus x2 over 2, and then of course y1 plus y2 over 2. Now we know what the midpoint is already. We know that the x midpoint is negative a half. So I'm going to say negative a half, and I would usually get that by adding this x value plus the x value of point C, which I don't know, and I would divide that by 2. Now there's many ways to solve this, but if you eventually do go ahead and solve it, you would find that x is going to be minus 1. So the x value of point C is negative 1. I would then do the same thing with the y values. I know that the y midpoint is 3 over 2, so I'd say 3 over 2 equals, and then I would normally have to take this 1 over here, plus this C's y value, which we don't know, and we'll divide that by 2. If you had to go work this out, you'd find that y is equal to 2. And so the coordinates of C would be negative 1 and 2. So guys, all I did there was I used the midpoint theorem in reverse. Another way that you could maybe think of it is the following. The x value here is 0, and the x value here is negative a half. So the length in the x values there is a half, and so if you do that onto the other side by C, it would go to negative 1. If you look at the y value over here, it's 1, and this one is 1.5, so it's gone up by a half. So to get from n to C, you would add another half, and so the y value would end up equaling 2. Question 4.3 says, show that the equation of the tangent CD is that. So we need to find the equation of tangent CD. Now we need to know that a tangent is always 90 degrees to a radius or a diameter. So what we can do is we can work out the gradient from n to C, or you can even do it from B to C. I'm going to do that. The numbers just look a lot better. I'm going to go from B to C, and I'm going to work out the gradient. So I'm going to say gradient of BC is going to be y2 minus y1 over x2 minus x1. And so that's going to be 1 minus 2 over 0 minus minus 1. And that gives us negative 1. Now we know that the gradient of a tangent is 90 degrees to the gradient, or it's 90 degrees to the diameter. So we can say that the gradient of CD multiplied by the gradient of BC should always equal the mathematical number of minus 1. It's a mathematical property. It must always equal minus 1. Remember that for 90 degree lines. And the reason for this is that we have a tangent perpendicular to a radius. Now the gradient of BC is minus 1, so it's going to be times by minus 1 equals to minus 1. And what we're going to find is that the gradient of CD is equal to 1. So now we know that y is equal to mx plus c. This is now for the equation of CD. And so that's going to give us y equals to m, which is 1, plus c. To find c, you just plug in a point. I'm going to plug in the point c, which is minus 1 and 2. And that's going to give us 2 equals to 1 multiplied by minus 1 plus c. And if you work this out, you'd find that c is equal to 3. We can then say that y is equal to x plus 3. And then you can just rearrange it to make it look like their answer. Y minus x equals 3. Question 4.4, quite an interesting one. It says, determine the values of t for which the line y equals to x plus t will not touch or cut the smallest circle. Now, have a look at this carefully. A lot of students miss this. That x there's a 1 in front of that. That means that the gradient is 1. And the line that we just worked out in the previous question also has a gradient of 1. So they're parallel. So we are looking for lines that are parallel to CD, like that, and they want to know, you can see what I'm doing here, they want to know what must t be equal to so that the tangent doesn't touch the circle. So if it touches the circle, let's say it does touch the circle over there, wait, let's do it, then what would the c value be? Or in this case t, which is the y-intercept. Well, the y-intercept there is 1, okay, so t would be equal to 1. If it touches the circle, if it's a tangent and it touches that circle, then the y-intercept up here was already worked out as 3. Remember, we worked out the y-intercept already. Okay, so what we want is that the t value should be less than 1, because then it's going to go down here, which is good, because we don't want it to touch the circle. So we can say t must be less than 1, or, what would you guys say? T should be greater than 3. So, because then the line would go somewhere over here, because then it would be higher up than 3. So you're going to get lines that go here and here, for example. I hope that makes sense. You might need to watch that again. We're now moving on to question 4.5. They tell us that they're going to take the smaller circle and they're going to move it down to point D. So it's going to look something like this. And now they want us to calculate the new center. What we can do is we can take the equation of line CD, which we worked out in question 4.3, where we said y was equal to x plus 3. We could use that to find the coordinates of D, because that is the x-intercept. So we make y equal to 0, and we would see that x equals negative 3. So the coordinates of D will be negative 3 and 0. All that we need to do now is look at the coordinates of C, and we need to see what happened. Well, the x values went from minus 1 to minus 3, so the x values changed by going 2 places to the left, and then the y values went from 2 to 0, so they went 2 down. That will be the same thing that will happen to this point over here. So the minus half, if you go 2 places to the left, will be minus 2.5. Right? So that'll be the same as minus 5 over 2. And then the y value at this point is currently 1.5. If that goes 2 down, it's going to be negative 0.5. And that's the end of question 4.5. So just to refresh, or to summarize what we did for that question, we found the coordinates of D, and then we saw what happened when you go from C to D. And what we found is that you're going 2 to the left and 2 down. So that is what will happen to the center as well. It will also go 2 left and 2 down. Question 4.6 is actually quite easy. They tell us that the quadrilateral OBCD, which I've highlighted, has an area of 2a squared. So guys, if we needed, and then they say find the value of a. So if we were to work out the area of the shape, it's not a kite, by the way. I know it looks like it, but it's not a kite, because if it was a kite, this length and this length would have to be the same. But what we can do is make 2 triangles like that, and then we can just add the 2 triangles together, and then the answer should be 2a squared. So for the first triangle, I'm going to do this triangle up at the top here. We know that it's half base times height. Now we know what the perpendicular height would be, and we know the base, and we know that this is a 90-degree angle because it's a tangent and a radius. So I'm just going to use this as the base, and I'll use this as the height. So we need to work out the length of CD. So let's do that first. So length of CD. Obviously you just use the distance formula. And you guys know how to do this. I'm going to quickly go fill everything in and get the answer, which is going to be 2 root 2. I'm going to leave it like that because that's the most accurate answer. And then we need to find the length of CB. I'm just going to do the distance quickly. You guys know how to do that. And that's just going to be square root 2. So to find the area of that triangle, so area of triangle BCD is going to be half base times height, which will be half of 2 square root 2 times by square root 2. If you do that, you actually just get a nice answer of 2. Now the area of the other triangle, which is this one over here, that's quite easy, because we know that this base length over here is 3, and this height is 1. So we can say area of triangle OBD is going to be a half. Its base will be 3 and its height will be 1, and that's 1.5. So now we just add those two values together. So 1.5 plus 2 is 3.5, and that's going to be the area of OBCD. But they've told us that that should be equal to 2a squared. So we can say 3.5 equals to 2a squared. Then you can divide by 2, which will be 1.75 equals to a squared. And if you take the square root of that, you're going to get square root 7 over 2. Moving on to question 5. Alright, so we need to simplify this. So this over here, I'm going to do that separately. So I'm going to say sin x over cos x times by sin x over cos x. Yeah, what I've done is I've just changed the tan. Now this cos and this cos cancel, and then this sin and this sin cancel, and so that's just equal to 1. So that already makes things really easy. So now we've got 1 plus. Now sin of 180 plus x. Now guys, this uses our cast diagram. And remember, in a cast diagram, you've got C-A-S-T, and 180 plus x is here. So sin is negative there. So that's going to become negative sin x. And then cos of 90 minus x, that's a co-function. You need to know those. That just becomes sin x. And so if we go simplify this, this is going to become 1 minus sin squared x. Now from grade 11, we should know that sin squared x plus cos squared x equals to 1. So if we take this over to this side, we're going to end up with cos squared x equals to 1 minus sin squared x. So that means that this is the same as cos squared x. Question 5.2. When I saw this over here, the first thing I thought about was this part of the formula sheet. For some reason it made me think of this part. But we can see that the sin is first and then it's the cos. So what we can do, or what I would do, is I would put a negative in the front, and then I would say cos squared 35 minus sin squared 35, because those are now the same. Then at the bottom, I would leave it as, well, or for now we can leave it. There's something I was thinking of doing, but let's leave it for now. Now, this is the same as this. So what we're going to do is we're going to take this part, and we're going to turn it into that. So what happens is that the angle becomes double. So it's going to become negative cos of double 35, which is 70. Then at the bottom, I can now see something starting to happen. I'm going to change this 4 into 2 times 2, sin 10, cos 10. Now have a look here, guys. Can you see that? It's that. So I'm going to change it into that one so it becomes double. So it's negative cos 70 over 2, because that 2 is already there. And then that part there becomes sin 20. Now have a look here. These two add up to 90. So this is a co-function. So you can choose to change the top one into sin 20, or you can change the bottom one into cos 70. Doesn't really matter. I'm just going to change the top one. So it's going to turn into negative sin 20 over 2 sin 20. Those cancel. And so our final answer is negative a half. When you get a question like 5.3 where they use the words, or when they say something like if cos 26 is m or cos 26 is m, then you can usually use a triangle. Now people always ask me, yes, but Kevin, which quadrant? Well, it's 26 degrees, guys, so that's quadrant 1. So what we do is we make a little triangle in quadrant number 1. We label this 26 degrees, and here's some advice. Always label this angle as well. So you can just do 180 minus 26 minus 90, and that's going to be 64. Sometimes they like to ask a question on that. Sometimes they don't, but just in case. Then they're saying cos 26 is m. Now, a little trick, what we can do is we can write that as m over 1, and cos is adjacent over hypotenuse. So that'll be m, that'll be 1. We can then do Pythagoras and get that this is 1 minus m squared. It says we need to find sin 77. Now guys, I'll be honest, this question 5.3 took me a bit of time to try and understand it. Usually they're quite easy, but this one is one of the more difficult ones that I've seen. The only link that I realized was 77, if you add 13, it makes 90, and 13 is half of 26. So there's some type of relationship there. I still don't know how it's going to work out, but there's definitely something happening over there. So I'm going to use a co-function over here. So we know that 2 sin squared, or yeah, we're just going to have it as that for now. Now that's sin 7. You can think of this like this, sin 77, and then square it. You can write it like that instead. Now I'm going to change sin 77 into cos 13. So this is how it's going to work. Now cos 13, there is some type of relationship happening over here. We know from our double angles that we've currently got this part, okay, and we could probably try get it to look like that. So let's write that out. Cos 2 alpha is equal to 2 cos squared alpha minus 1. Now if I replace this angle here with a 13, which is what we have, right, then this angle must be double, so this must be 26. Here's how it's going. This is quite a difficult one, I will not lie. So we have this part over here, so we can say 2 cos squared 13 must be equal to cos 26, and then take this minus 1 over. There we go. So now it's cos 26 plus 1. Now cos 26 is equal to m, and so we can say that this is equal to m plus 1, and so that would be the final answer. Now let me summarize what we just did there. We didn't need a triangle after all, but sometimes you do, sometimes you don't. So it started off by asking us 2 sin squared 77. So I then changed that to 2 sin of 77 squared, just to make it a bit easier to understand. Then I changed the sin 77 into cos 13 squared. Then I realized that from this identity here, cos 2 alpha equals to 2 cos squared alpha minus 1. If I change that to 13, the alpha to 13, then it becomes cos 26, because that's 2 times 13, equals to 2 cos squared 13 minus 1. I have this part. Can you see that? It's over there. And so we can say 2 cos squared of 13 is equal to cos 26 plus 1, which is m plus 1. Guys, that is tricky. If you didn't get that, it's okay. I sat here for quite a while trying to figure that one out. Moving on to question 5.4. Alright, so this over here, guys, you should see a compound angle immediately. You see, because what we have is a sin cos, cos sin, And here we have sin cos sin. So we're going to take it from here and we're going to write it like this. So we can say that this is going to be equal to the sin of x plus 25 minus 15. And so that's going to be equal to the sin of x plus 10. Now they're saying determine the general solution of f if it's equal to tan 165. So then I can say sin of x plus 10 equals to tan 165. Now tan 165 is just a number. So I'm going to type that in on my calculator, tan 165, and it gives me negative 2 plus square root 3. But I'm rather going to write it in the decimal form, which is negative 0. Now we don't want to round off here because it's not the final answer, 79491924. Now we can get our reference angle by saying shift sin. Now remember, we don't put the negative on the calculator, so you put all the other stuff, 0.2679491924, and that's going to give us a reference angle of 15.54 degrees. And now what we can go do is work in our quadrants. So it's telling us that sin is a negative. So sin is negative in quadrant number 3 and also in quadrant number 4. So so we can now say x plus 10 equals to 180 plus our reference angle. And then we can say here plus k times 360. Some schools say plus n. It doesn't matter. K is an element of z. And then we can say for quadrant number 4, x plus 10 is equal to 360 minus the reference angle plus k times 360. K is an element of z. Now you just go work out x in both of those. So for this one you get x equals to 185, I don't know where that came from, 0.54 plus k times 360, and I should be saying k is an element of z, I'm just running out of space. And then over here we're going to get 334.46 plus k times 360, k is an element of z. Alright, then question 5.4.2, quite an interesting one. It says determine the values of x in the interval from 0 to 360 for which this graph, which we already summarized as this, will have a minimum value. So sin x plus 10 must have a minimum value. Okay guys, so what we do is imagine a normal sin graph, just a normal one. Well, that would be like this. So where would the minimum be? Well, the minimum is over there at 270 degrees. Now, what have they done to this graph? Well, they've taken a normal sin graph and then in brackets it says x plus 10. So they've shifted the graph 10 degrees left. So this 270 would now go to 260 degrees. And so therefore, our answer will be 260 degrees. Question 6.1 says, write down the range of f. Now this graph that I have here, I don't know if it was like this for the people in 2019, but the quality is terrible. I can't see anything. But what I can see from these equations is that this is definitely going to be 1, and this is definitely going to be minus 1. Now this graph is a normal sin graph that has been moved down by 1. So this would be negative 2. So the range, we would say y is an element from negative 2 up to 0. The reason I include the minus 2 and 0 is because the graph actually touches those points. Now 6.2, write down the x value for which the graph f is decreasing. Guys, decreasing is like whenever the graph is doing that. Okay, so it would be for this piece, actually only there. So it will be when x is between 90 and 270. So we can say x is an element between 90 and 270. I'm not going to include the 90 and the 270 because the graph is not decreasing at 90 and at 270. Question 6.3. Now 6.3 is an extremely good question. They're saying P and Q are points on the graph G and F respectively, and then PQ is parallel to the y-axis. If PQ lies between A and B, determine the values of x for which PQ will be a maximum. Okay, so they're saying that P is for G, so P will be somewhere over here, for example, and Q is for F, so Q would be somewhere here. Now they want to know where will this maximum length be a maximum. So it's probably going to be here, for example. But now we need to work out what the angle is going to be. It might even be here. So we can't just assume that it's going to be whatever that x value is at that turning point over there. So can you guys remember in grade 11 when they used to give us graphs, like in paper 1 I'm talking about, where they would give you a parabola and then they would give you a straight line, for example, and then they would ask you to find the maximum length? Well, what you would normally do is you would say y, you would take the y of the top graph minus the y of the bottom graph, and you would do something like that. You would find the turning point of whatever this equation became. Do you guys remember that? If not, let me quickly try to refresh your memory. They would have given you a parabola back in the day. They would have said like y equals to negative x squared plus 4x. And then they would have given you a straight line like y equals to x plus 1. Then what we used to do is we used to say y top minus y bottom, and that would be the length between the two graphs. So the top one was this. So we would say minus x squared plus 4x minus, and then we would plug this equation in brackets, and that would represent the length. We would then go simplify this, which would eventually give us this over here. And then to find the maximum, you would find the turning point of this equation using something like negative b over 2a, and then you would plug that answer back inside. If you're battling to understand that, it's okay. It's not the end of the world. It's only this question, okay? It's a very tricky question. Now, I could sit and explain this over and over and over, but yeah, it's going to end up taking a long time. So, we're going to use the same approach. To find the length of PQ, we're going to take y top. Now, the top graph is graph G, which is cos 2x. Then we're going to say minus, and then we're going to minus the other graph, which is sin x minus 1, always in brackets. Now, that's going to give us cos 2x minus sin x plus 1. Now, I don't like this cos 2x. I know that it can be changed by using the formula sheet. And so here we go. I can see that I've got this, and I would like to have more sin, because then I can get like a trinomial, for example. So I'm going to change it to 1 minus 2 sin squared x minus sin x plus 1. And that's going to be equal to PQ and PQ. And that's going to be minus 2 sin squared x minus sin x plus 2. Hey, there we go. Just like in grade 11, we have something that looks like a trinomial. So we can use negative b over 2a to find the turning point of that, because that's how you find maximums. So what we do, and you could use calculus, but we don't use calculus with trigonometry in grade 12. So you might have thought, hey, don't we usually use calculus for maximums? You are correct, but we can't do it in trigonometry. I mean, it does work, but you guys haven't been taught how to do that in grade 12. It's a bit beyond the scope of what you guys focused on. Alright, so what we can do is we can use negative b over 2a. So we're trying to find the turning point, and that's going to be negative b over 2a, where your b value is negative 1, so that's negative 1, over 2 times by negative 2. And that's going to give us negative a quarter. So normally in grade 11, you would say x equals to negative a quarter, but now we're going to say sin x equals to negative a quarter. So we're going to go sin x equals to negative a quarter. If you're battling with this question, it's absolutely fine. This is quite a tricky one. It's not an easy question. Now we can use general solution. Remember, we don't use the negative. So we first find the reference angle by saying shift sin of 1 over 4, and that's 14.48. 14.48 degrees. Now we need to work where sin is negative. Now sin is negative in quadrant number 3 and also in quadrant number 4. Sure, for someone who doesn't like general solution questions, 2019 would have been a difficult year to write your exam. Alright, so now what we can do is we can say x equals to, now quadrant 3 is 180 plus, now it's going to be plus the reference angle. Then I'm going to say plus k times 360, k is an element of z. And then x equals to 360 minus 14.48 plus k times 360, k is an element of z. And so if you had to go solve this now, you would get that x is equal to 194.48. I'm not going to write the element of z the whole time. Sorry, there's question 7 that's about to start. And then for this side, you're going to end up with 345.52 plus k times 360. Alright, so those would be the two answers over there. So it would be at 194, which is over here. Oh, and then it happens again at about 345, which is over there. Alright guys, question 7. Question 7.1 says, determine the length of AK in terms of x. Now, a lot of you grade 12s and 11s, when you get to grade 11, you learn about the new formulas like A over sin A equals to B over sin B. And then you forget about the normal grade 10 trigonometry, which is when you have a 90-degree triangle, you can use the normal sin, cos, and tan. You don't have to, but you can if you want to. So I'm going to do that. So I know that we're looking for AK, which is opposite. We have the hypotenuse, and so I'm going to use sin. So I'm going to say sin 60 equals to opposite over hypotenuse, which is x. And so this means that AK is going to be equal to x sin 60. Now, sin 60 is square root 3 over 2. And so we can just say that AK is going to be equal to square root 3 over 2 x. Question 7.2, write down the size of angle KCF. They tell us in question 7.2 that this is a rhombus. Now, a rhombus has lines that are parallel. So if those are parallel, then this angle and this angle should add up to 180 degrees because of co-interior. So we can say that angle KCF is going to be equal to 120 degrees because of co-int angles, and the reason is that DE is parallel to CF, so it's going to be 120 degrees. Question 7.3 is extremely good. They ask us to determine the area of AKF. Oh, and they also tell us that this angle here, is Y. They tell us that that angle's Y, and they want the area of this triangle. Now guys, that's not a 90-degree triangle, so we're definitely going to have to use the formula A, or half A, B, sin angle C. You know that one, right? So, have a look here. This formula only works when you have two sides and an included angle. So we've got the included angle, so we probably need to go and find this length over here. So that's the goal for now, guys. Let's try find the length from K to F. So let's write that down so we don't get lost. Goal. Find KF. So, guys, they've told us that this gray or the shaded shape is a rhombus. So if we could work out this length, then we've got this length because they said it's the same. Then, because it's a rhombus, all four sides are the same, so that'll give us a lot of information. So we could use this triangle here, or this triangle, and we could try find the length of DK or KD. I'm going to use the normal sin, cos, tan because it's a 90 degree. So I'm going to say adjacent and hypotenuse. So I'm going to say cos 60 equals to the adjacent, which is DK, over the hypotenuse. If you go work this out, you'd find that DK is a half x. Alright, so that means that this part here is a half x, and so it also means that this part here is a half x. And so the entire length of this rhombus is x. So that means this length is x, this length is x, and this length is x. Now guys, I'm going to bring our attention back to this triangle, where we now have, let me draw this out for you, check this out. We know that this is a half x, this is x, and we know this angle is 120. So we can use the cos rule to find the opposite side. And that's the length we were trying to find. That's why this question is worth 7 marks. It's a lot of steps. So the cos rule is this one over here. So we're looking for KF. So it's going to be KF squared equals to. Now it's going to be a half x, and then in brackets squared, plus x squared. So that's minus 2 times a half x times by the cos of 120. Now we can simplify all of this. Kf squared is going to be equal to a quarter x squared plus x squared minus x squared, because the 2 and the half cancel out, and then cos 120 is negative a half. So now what we have is kf squared equals to, if you go simplify all of this, a quarter plus 1, and then these two negatives are going to become a positive, you're going to eventually end up with 7 over 4 x squared. I'm now going to get kf alone by square rooting. Now remember, you've got to square root the x squared and the 7 over 4. Square root of 7 over 4 is going to give me, or give us, square root 7 over 2, and then the square root of x squared is just x. There we go, guys. So now we have this length. That was our goal, to find that 7 over 2 and then x. Okay, now we can do the area rule for that big triangle that we were trying to work out. And so that's going to be a half. And then the a could be, for example, square root 3 over 2, and the b could be the square root 7 over 2, and then cos, not cos, sin of y. And so you could go type all of this in on your calculator. Oh, I left out the x's. My goodness. And then sin of angle y. Now we can just, if I was you guys, I would type this in the calculator. Of course you can't type in the x's, but you can type in the numbers. And that gives square root 21 over 8 x squared sin y. If you struggled with that one, guys, do not be discouraged. That one was difficult. Alright guys, here's question 8. So 8.1.1 says determine the value of r. That's an easy one. This is a parallelogram. How do I know that? They've told us. And we can see that these lines are parallel. So it means that this one and this angle should add up to 180 because of co-interior. So we can instantly say that angle r is going to be equal to 80 degrees y, co-interior angles, due to the fact that QW is parallel to RK. Now, moving on, question or angle P. Alright, for question P, I don't quite know why it's only worth 2 marks. It's actually relatively quite a long question. So what I would do is I would say that S2 is the same, because what you should see is that this is a cyclic quad. Can you see that? So that means that this angle should be the same as the opposite angle. We know that for a cyclic quad. So this means that angle Q should equal 136. Why? Because of exterior angle of cyclic quad. That means, therefore, that Q2 is 36 degrees. Or we can just think of that whole thing as 136. Now, in this cyclic quad, we know that any quadrilateral, the angles should always add up to 360. So we know this, we could easily work out this one, and that'll give us access to P. If you see a better way than that, then that is fantastic, but I couldn't see it. Alright, but first we need to go find S1. So we can say that S1 is going to be equal to 44 degrees. Why? Because of angles on straight line. And so now we can say that angle P should be equal to 360 minus 136 minus 80 minus 44. And that's going to be some angles quad. And so that's going to be 100. So angle P is 100 degrees. Now in the next question they say PQW. Well, we've already proven that, so I'm just going to say proven. Okay, you would get your marks because they would see how you got the previous one. And then 8.1.4, the angle U2. Well, what I would do here is I would find angle U1. There are other ways to do it, but some students aren't comfortable with certain methods. So the easiest way is to find angle U1. So you could say angle U1 is 180 minus 36 minus 100. That's because of some angles triangle. And so U1, angle U1 is going to equal to 44 degrees. Now that's U1. Now we could do sum of angles on a straight line to find U2. So we can say therefore U2 is equal to 180 minus 44. And that's because of some angles straight line. And so that means that angle U2 is going to be equal to 136. Okay, guys, so in question 8.2, they would like us to prove that angle EFD, which is this one, is the same as ECD. Now, of course, they look like they're the same because we are so used to having circles going around, then you could use angles in the same segment. But we don't have that. What we can do, though, is I'm going to work in this triangle, and we can use the cos rule in reverse. So, in the cos rule, this side is always opposite the angle, and then this part is the angle. So let's let f be the angle. Then the 7 is the opposite. So it'll be 7 squared equals to 9 squared plus 5 squared minus 2 times 9 times 5 cos. Now we don't know the angle, so we just say cos f. Now what we can do is we can write that as 49 actually. And then these two numbers we can put together as 106, and then this we can put together as 2 times 9 times 5, and that's going to be minus 90 cos f. What I see a lot of students try to do is they minus these two numbers. Now we can't do that because the cos f is attached to the 90. So next what I would do is I would take the 90 cos f to the left, and then on the right hand side you would have 106 minus 49, which we can actually just simplify to 57. Next, we can divide by 90, and then we can say shift cos. And that'll give us 50.70 degrees. So we have found angle F, 50.70. Now we can do the same technique for angle C by using this triangle. So I'm going to go a little bit faster now. So now the 14 is the opposite, so I'm going to say 14 squared equals to 10 squared plus 18 squared minus 2 times 10 times 18 times cos C. Now you guys know how to get everything by itself, so I'm just going to quickly do it to save us time. And hey, would you look at that, we get exactly 50.70 degrees. Then we can say, therefore, those two angles are the same. Okay, the next question wants us to prove that angle DFC, which is now this one, they want that to be the same as DEC. But guys, now we need to be smart. I was almost tempted to go do the same thing all over again. But, can you guys remember, how do we prove if something is a cyclic quad? Well, there are three ways. First of all, if it is inside a circle and it touches in 4 places, then it is a cyclic quad. Actually, there are 4 ways. That's the first way. Then it's a cyclic quad. But if there is no circle, then you need to look for the following properties. Either the opposite angles must equal 180. That's method 2. Method number 3 would be when you have an exterior angle, like 70, it should be the same as the interior opposite. That is number 3. Number 4 is if you can prove, if it looks something like this, if you can prove that these are the same, then it's a cyclic quad. Now guys, we've just done that. Check, we did that in the first question. So that means that this shape is a cyclic quad. So we can tell them that. We can say that EFCD equals a cyclic quad. Why? Because normally it's called angles in the same segment, but this will be converse, because it's the opposite. Converse, angles, same segment. So, because it's a cyclic quad, then it automatically means that these two have to be the same. Because if it's a cyclic quad, then it's almost like there's a circle there. The circle doesn't have to be there, though, for it to be a cyclic quad. And so we can then say, therefore, angle E, actually we should call it what they said, DFC equals to DEC, angles in same segment. Alright, in this question they would like us to prove that this angle T1 is a quarter x, and it's for 7 marks. Well, this isn't actually too bad. We should know that you've got something called angle at center equals 2 times angle at circumference, and that normally looks like this. If this, for example, is 80, then this angle up here is normally 40. But what some students don't know is you can do this in reverse. If you can work out this angle, which would be 360 minus 80, that would be 280, then you can do this, and then this angle would be half of that, so this would be 140. So, if this angle is x, then how much would this be? Well, that would be 360 minus x. So let's say that O2 equals to 360 minus x, and that's just angles around a point. Now, what we said earlier is that that will be double angle M. Now, we know that angle M will be half of that, so angle M would be 180 minus a half x, because of what I just showed you guys now, with angle at center equals 2 times angle at circumference. So let's just write that here, angle at center equals 2 times angle at circumference. And so this would be 180 minus a half x. Now, we could use the fact that this is an isosceles triangle, and we could work out what T2 and P1 would be. So we can say T2 equals to P1 because of angles opposite equal sides. And then we can say T2 equals to P1, which is equal to 180 minus, now I'm just doing sum of angles in a triangle, and then you divide that by 2. If that part doesn't make sense, what I'm doing is I'm saying that if this is 40, and if this is isosceles, then to work out these two, you could say 180 minus 40, and then you would divide that by 2, so that it can go half, half. If you had to eventually work this out, you'd see that angle T2 equals to angle P1 is going to be a quarter x. Okay, so I'm just going to fill that in. Quarter x. Now we're trying to prove that this is a quarter x. Now, guys, check this out. There's a tan chord theorem happening over here. Tan chord theorem works when you have a tangent and a chord. Okay, now look at the angle in between the tangent and the chord. Well, that's angle T1. That angle will be the same as the angle formed by the chord. So look at the chord TM. Can you see that TM comes together at P1? Therefore, we can say that T1 is equal to P1 because of the tan chord theorem. Therefore, angle T1, or let's call it STM like they did, is equal to a quarter x. This question is actually the proportionality theorem proof. What we do, so let's look at this part first. AD and DB. So what we do is we work in this triangle, and we are also going to work in this triangle. So I'm going to try to squeeze this in. This is quite a long proof. So in triangle ADB and triangle BDE, okay, so those are the two triangles that we're working in. We're going to find their area. So we're going to say area of or let's first do a construction. What I want you guys to do is quickly have a look at the following. Can you see that they both have the same base? That's this line over here. Or they lie on that same line. So the height of those two triangles, where do they both meet? Well, they both meet at point E. Let me draw it a bit neater so you can see that. See, they both meet at point E. So to work out their height, you would go from point E, and you would draw a 90-degree line to that black line. Something like that. So the height of those two triangles is the same, and so we'll call that H1. So we'd say here, construct H1. Okay, so now we can say that the area of triangle AD, sorry, that wasn't meant to say B, that was meant to say E. I do apologize. ADE over the area of triangle DBE is going to be equal to a half. Now the base, let me show you guys, the base of the pink triangle is going to be AD, and its common height, we're going to call it H1. Then for the green triangle, it's a half BD, and it's also h1. So the h1s cancel, the halves cancel, and so we are left with AD over BD. Alright, there we go. Now we're going to do, so we've done with those triangles now, so now I'm going to take all these away. Now we're going to try find these two sides. So what we do is we work in this triangle again, but then we also work in this triangle over here. Now, their common baseline is this one. Let me do that a bit neater. So where do those two triangles meet? Well, they both meet at D. To find the height of the triangles, you connect this point at 90 degrees to the line we've just drawn. So there, and let's call that H2. So now we can say, I'm going to do this in a different color. I'm going to say in triangle ADE and triangle ECD. Alright, now we're going to construct H2, which we've done. Okay, so now we're going to go work out their areas. So we're going to say area of ADE over area of triangle ECD, and that's going to be equal to a half. This will be AE times H2. I'm using half base times height, and then this triangle, the pink one, is going to be half EC as the base and H2 as the height. So those cancel and those cancel, and so we're left with AE over EC. Awesome, so that's all good. Now, what we do now, guys, is we realize that in these two expressions, number 1 and number 2, we have something in common. We've got area of ADE and area of ADE. What we are going to try to do is get the area of AD alone in both of those expressions so that we can make them equal to each other. So for the first expression, I'm going to arrange everything and get area of triangle ADE alone. If you do that, you're going to get AD over BD multiplied by triangle DB, the area of triangle DBE. Like that. Then I'm going to do the same with expression number 2. So I'm going to get area of ADE alone in that one, and that's going to be AE over EC times by the area of triangle ECD. Okay, so now because these two are the same, we can make those two expressions equal to each other. So we can then say, therefore, AD over BD multiplied by area of DBE must be the same. So you see, I'm saying that this part must be the same as this part. So it'll be AE over EC times by the area of triangle ECD. Okay, guys, we are nearly there. Now, what I want you guys to do now is have a look at these two. This area and this area. So those two triangles are DBE, so that's this one, and ECD, which is this one. They both share the same common base. Can you see that? It's this one here. And they also have the same height. The reason is that they are going in between two parallel lines, so their height is the same. Okay, can you see that? They have the same height. I'll quickly show you here. If I have two triangles, and those two triangles are in parallel lines, no matter how I draw the triangles, their vertical heights have to be the same. So these two triangles have the same base and the same height. So surely their areas are exactly the same if area is half base times height. So we can say, but area of triangle DBE is the same as area of triangle ECD. And you can just say which lines are parallel for that. So you can say DE is parallel to BC. So that means that these two parts could cancel out, right? Because they're the same. You're dividing, they cancel out. And so look at this. Therefore, AD over BD is equal to AE over EC. And there we go, guys. And finally, guys, we are at the last question. Well done if you have been sticking with me thus long. Or not thus long, that doesn't even make sense. This long. So let's get started. Last question, 10.2. Write down three other angles equal to x. Okay, so we can see that x is up here. Now, we know that if you have two tangents that come from a common point, their length is the same. So we can say that, I don't even know what this letter is. Alright guys, I couldn't really figure out what that letter was, but if I look here, it must be a T, so don't know what happened there. That's a T. So we can say that the lines ST are the same as the line VT. That's because of tans, or tangents, from common point. That's a theorem. So these two are the same. That means that these two angles must be the same. Therefore, angle V3 must be the same as angle S2 because of angles opposite equal sides. Okay, so we found one angle so far. Now we can use the tan chord theorem. We can actually use the tan chord theorem twice. The tan chord theorem needs a tangent. It also needs a chord. So let's look at that chord. You then look at the angle that is in between those two, which is this one. And that angle will be the same as any other angle formed by this chord, by the chord that we highlighted. So that's going to be this one over here. So angle R is also going to be equal to x. So we can say angle R is equal to x because of the tan chord theorem. Many students ask me, Kevin, can't we also use the tan chord theorem maybe for this angle here? Guys, it has to be on the edge of the circle. Now, we could technically use this tangent and this chord, but then that's just going to make the same angle, so we can't do it again. But what we can do is realize that these two lines are parallel, so we can use corresponding angles with W3 and R. Can you see it? There's an F there. I'll quickly highlight it for you so you can see it. Can you see that? There we go. So this means that W3 is equal to x because of corresponding angles. So we say corresp angles, and that's because RV is parallel to WT. Okay guys, so we found our three angles that are equal to x. It's that one, and then we have V3. That was for 6 marks. That's awesome. 10.2.2. Prove with reasons that WSTV is a cyclic quad. Let me highlight that for us. Alright guys, there are 3 ways that something can be proven as a cyclic quad. The first one is when the opposite angles add up to 180. The second way is when the angle on the outside is equal to the angle on the inside, the opposite angle on the inside, like that. The third one is when you've got a shape that looks like that. If you can prove the angles in the same segment, then it's a cyclic quad. Now this is what I tell students. If the cyclic quad looks open like that, or like that, then it's obviously those ones. But if it's got the bow tie looking thing, then it's probably the third one. Okay? So if we look at that cyclic quad, it has got the bow tie. Can you guys see it? I'll show you quickly. Can you see it's got the bow tie? So we should start there. It might not be that, but let's at least start there. So what I then do is I take one side at a time. I take this side, and I see which angles does that one make. Well, that one makes this one, and that, and it also makes this one, and that. Let me do that again. That actually doesn't sound very clear. So I let that be my base, and so I can try to see if these two are the same. So they don't really look the same at the moment. We don't know what W2 is. We could try to find it, but let's first see if there's an easier way. Okay, so then I go to another side. I go to this side, for example. Now I look at the two bases. It would be or the two bow ties. It would be there and there. They're not the same. Then I would maybe go here. And the two sides for that one would be this one and this one. Aha, and they are the same. Can you see that? So let me show you what the bow tie looks like. There, and there, And then let me just erase this little piece. Whoops. And there we have it. Can you see that bow tie? Perfect. So then what we can say is that W3, angle W3 is equal to angle V3. Okay, so we've already proven that. So we can say, therefore, this thing is a WSTV equals a cyclic quad. Why? Because it's angles in the same segment, but we're doing it backwards. So we say converse angles in same segment. Awesome. The next thing is WRV is isosceles. WRV. So that's this triangle over here. We should also remember from the previous question that we proved that that shape was cyclic. So because it's cyclic, you can use the circle properties. That's what a cyclic quad is. So we could say, or we could use this bow tie over here, and we could say that angle W2 must be the same as S2. W2 must be the same as S2 because of angles in same segment. Guys, because it's a cyclic quad, we can do this now. We can pretend that there's a circle around it. We can almost pretend that there's a circle going there. Because it's a cyclic quad, that's allowed. And so, therefore, W2 must be X. So what we can now do is we can say that W1, which is over here, would be 180 minus 2x. That's just because of angles on a straight line. Can you see it there? There are other ways to do this, but this is the way that most students prefer. So we can go angles on straight line. Then to find angle V1, we could use sum of angles in this triangle over here. So we could say that angle V1 is equal to 180 minus x minus, now this part must go in brackets because it's more than one term, and the reason for this is sum angles triangle. And so if we eventually do this, or if we go through it, you would find out that V1 is equal to x. Now check that out. That's x, this is x, so that means it must be an isosceles triangle. Therefore, WRV is an isos triangle. Alright guys, two more questions. So, this one says, prove that WRV is similar to TSV. WRV similar to triangle TSV. Okay, so, fairly easy. We can just say angle V3 is, we already learned that that was the same as angle R. That was tan chord theorem. Or you could even say proven, because we have proven it already. We can then see that S2 is equal to V1. Okay, there's no real reason. I mean, they're just both equal to X, so we could say proven. And then we know that, therefore, the third one, which would be angle STV, which is this whole angle, must be the same as W1. And that's just because of sum angles in a triangle. Remember that, guys. The third angle is always the same because of sum of angles in a triangle adding up to 180. Therefore, triangle WRV is similar to TSV. Alright, last question for the entire exam, guys. Thank you so much for sticking this out with me. I hope you've learned from this. Now, when they do a similarity question in grade 12, the next question, you typically want to, oh, I forgot, we should have said here angle, angle, angle. Now, for question D, what you want to do is you want to take the previous question and just make ratios. You know these ratios, WR over TS equals to RV over SV equals to WV over TV. And you must give a reason for that. It's corresponding sides in proportion. Okay, now what we do is we go circle whatever they have. So they have RV. Do we have RV? Yes, we do. Do we have SR? No, we don't. That's okay. KV, do we have? No, we don't. And TS? Yes, we've got TS. So it's a little confusing as to what we should do, but at least we have that for now. So the WR and the SV, that's the problem. So let's go look at WR. WR is here, and SV is this one. Some of you might not have seen this, but sometimes they like to do this at the last question of these exams. These two lines here are parallel, so we can use the proportionality theorem in this triangle over here. And we're going to try use as many of the sides that they have. So they have let's see, SR. Okay, so we're going to try use SR. And they also have KV. Okay, and then we're trying to get rid of WR. Okay, so that's that one. And we're also trying to get rid of SV. So what we can do is we can do something like this. We can say WR over SR. You see what I said there? I said WR over SR would be the same as KV over SV. Alright, so what I'm going to do now is I'm going to take this one over here and I'm going to get WR times SV by itself. So WR times SV equals to RV times TS. I'm going to do the same with this one. So that's going to be WR times SV equals to KV times SR. I'm then going to make these two parts equal to each other. So that's going to be RV times TS equals to KV times SR. Aha, and then you can just divide and do all of that stuff. And eventually you'd end up with RV over SR equals to KV over TS. And there we go, guys. Thank you so much for watching. Please like, share, subscribe, do all of that YouTubey stuff. And also remember that in the description I've got a link to my course, which is currently on special because it's the end of the year. There are over 700 videos packed with maths and physical sciences to help you in your exams. Thank you very much for watching, and all the best, guys.